So I give you a little bit of disclaimer before we start. First of all, the lectures which you're going to hear, they are not going to be very deep. So I will not go into specific subjects deeply. Instead, I feel that my responsibility is to give you an overview of what's going on in the area of software design. So I will try to touch different topics, different things, and allowing you later to research by yourself. So I don't want to replace a Wikipedia for you or books for you. I know much less than almost any book you can find in the market about specific subjects. For example, we're going to talk about UML. I'm not going to tell you all the details about UML. I know much less about UML comparing to, for example, Martin Fowler, who wrote an excellent book about UML. We're going to talk about, let's say, NoSQL, the design of NoSQL databases. I'm not going to go deeper and explain you how they work in details. I will just touch a little bit and show you that you may be interested to go deeper by yourself. So I'm not a replacement of Wikipedia for you. I may not always be accurate, so don't expect me to be exactly accurate. I may make mistakes. You're welcome to correct me and improve them. And this is all presented first time. So I haven't done this course before. I'm doing this for the first time, so be prepared for mistakes. This is the list of topics. They're basically the contents, the agenda for 16 lectures. I posted that on Telegram. You saw that before. Some of you made some comments that something is missing here, for example, functional programming, or for example, the version control systems like Git. Certain things will be corrected. Probably I will change a little bit the agenda. I will change a little bit, but in general, we will stay like that. So we'll start from understanding what design is for, then we go into requirements, then we go into the process of how software design is supposed to be organized and disciplined. Then we go into object-oriented, of course, design is one of the most powerful design approaches in modern world. Then we go into patterns, lecture number 6, we go into patterns, anti-patterns, refactoring. Again, I'm not going to tell you much about every pattern. There are many of them. You can find many books about them, but I will show you what they're for, what there's the anti-patterns for, how you can use them, what is refactoring, what it's for, and so forth. Then lecture number 7, we go into unified modeling language, which some of you already have heard about, I believe. That's what your comments were about. So you said that you already been taught UML. Is it true? Have you? Okay, you know what it is. All right. So. I also know so. So don't expect me to give you, detailed explanations about UML, but we will talk about it for the full pair of lectures. Then we go into a family of UML standards, because UML is not only about diagrams, not only about pictures, but also about quite strict formats and standards for defining design decisions, for specifying design decisions, and actually exchanging them as well. So UML is not only, especially UML 2.x, like 2.0 and then 2. Other numbers. It's a family of interesting standards. Then we go, design of the software cannot exist without the design of data. Did you have any course about database design? Okay, so you know what is SQL, right? And do you know what is NoSQL? Yes. You also know that. Okay, so that's good. And do you know what is IDEF? That you probably don't know. So we will talk, less about how databases work, but we will talk about how we define the design of the databases. Then we go into design for continuous delivery. Again, I think most of you know what is continuous delivery, right? DevOps, continuous integration, you know that. No. Oh, that's good. So we're going to talk about continuous delivery, but not how it works, because this is, again, not my subject, not for this course. But we're going to talk about how we design continuous delivery pipelines, so how we structure the way software is delivered. Then we go for microservices. Microservices, APIs, RESTful, these things are for more like decisions you make in the design. So until that, we will talk more about format of the design or how you structure the design, but not what you design, not what technical decisions you make there. It's more going to be about what instruments do you use to make these decisions. And then in the second part of this long course, we will talk about what decisions you make. Like, do you go for microservices or you create monolithic architectures? Do you go for RESTful API or you use, XML interfaces? So that's we'll compare those design decisions. Then we go for serverless design in cloud. I put together the serverless and cloud. Who knows what serverless is? That's quite a trend on the market right now. Of course you know what is cloud, right? You've heard about that. iCloud at least. So cloud, you know what it is. We designed for cloud for the last 10 years, but serverless is something new on the market. It's the recent a few years. Everybody talks right now about serverless architectures, how it's great, how it's popular. So we will talk about that and discuss how they work. Then lecture number 13, we go for test-driven development. Who of you know what are unit tests? You do, okay, 30%. So we will talk about not only unit testing, but test-driven development, which some people consider dead for the last 10 years. I don't think so. So I will show you how it's dead, how it's not dead. We'll give some examples of how test-driven works and why we need tests. And then the very interesting part is test anti-patterns. This is one of my favorite topics actually. So people, when we write tests now in this modern development, we make a lot of mistakes. Mostly people, in my experience, make mistakes when they write tests. So this is the area where we create the most of the mess. So if you want to find messy code, then you look into unit tests. And we will discuss how we make those messy code while writing test cases, unit tests. And then lecture number 15, we talk about metrics. Coupling, cohesion, those are two metrics which are, which exist for, I don't know, maybe 30 years on the market. And there are many new metrics which were introduced after cohesion and coupling. So we will discuss how we can measure. All of the previous discussions were about design, how to format the design, how to make design, what are the good design decisions, what are the bad design decisions. And in the end, we're going to talk about how we can measure the design objectively. Not by intuition, not by emotions, but actually how we can put numbers on the work we do. How we can compare one design to another design by numbers. And finally, lecture number 16, we will try to talk about the future software design. So what is missing now, what we're looking for, what's the next 20 years will be about. Because you will create software in 5 years, in 10 years. Probably the best software you will create is going to be in 10 years. The next 10 years you will learn, make mistakes, create some not so good software. And in 10 years, there will be the moment of time when some of you will actually create something beautiful. So what it's going to be, what's the future, what we are prepared for, we will make some guesses at the lecture 16. That's the structure. Any complaints, any objections, any corrections? Yes?
Question?
Yeah, go ahead.
Many of us from different fields, for example, there are students from software development, there are from data science. So what would this course give us all, like as any programmer, who's doing, for example, data science, machine learning, and also back-end, what can we get from this course?
Okay, yeah, the question is what do we get from you, what can you get from this course coming from different areas? Some of you are data scientists potentially, some of you are programmers, some of you front-end designers. So what are you going to get from this course? That's a good question. I didn't prepare a slide about that, but I can answer. I think that you will get an overview of what's going on in the area of software design. And then you decide for yourself which one is more important for you, which one is less important for you. So I will introduce you to the topic which is called software design. So what you're going to get, will you write better code after that? I believe yes. Will you create better software being data science, being in the area of data, I don't know what it's called, data programming or data science as it's called now, or in the area of web design or in the area of tools design or whatever, then will your software will be better? Yes, I believe it will be. It will look better, it will work better, it will be faster, it will be more maintainable, more performance-wise, it will be better. Will you, probably the most important outcome you're going to get is that you will get more pleasure, you will enjoy the development of the software more than you would do before this course. Let me put this claim on the table. So you will probably, see more pleasure and more fun in your day work after my course. That's what I hope for. The first one is about, I called it README versus IEEE, RUP, SWEPBOOK, CMMI, all those things. So we will talk first about the design vary from two quite opposite approaches. The one is less formal, another is very formal. So who knows what is RUP? Who knows what is CMMI? Okay, so I'll introduce you to new things today. And who knows what is README? I guess everybody. So you're from the young generation, so you know how to design README, but you don't know how people were designing software 20 years ago, 30 years ago, and what knowledge they managed to aggregate and how they wanted us to design. Well, let's start first from the definition of design. So what is design? I'll give you some quotes during my course, and I will try to refer to the books, which I suggest you to read. All of the books which I refer to, I suggest you to read sooner or later, which will educate you pretty well. So this is a quote which I like. They say that design is not about, if you see the second part of the quote, they say that usually we think that design is something that goes after requirements and before programming. So first people think about what needs to be designed, like the system has to be developed, it should be a mobile application where I can post my photographs, and let's call it Instagram. So that's our requirements. And then goes the design. So okay, we sit together and we decide we need probably 10 servers, and we probably need like, you know, a little bit like a few Java code and a piece of Ruby code and a little bit of JavaScript code. That's how it's going to work. And then, okay, let's sit together and implement. So usually people think that design phase is between requirements and implementation. They say it's not true, that design is something that starts from the beginning and goes till the very end, till even the modifying of the software, which in my experience is the largest part in any software project. So when you understand what needs to be done, and then you design how it's going to be designed, you decide how many servers you need and what programming languages you need, and then you implement it, and then you finish that, and then you start modifying it. And most of the money, and most of the time, and most of the efforts you spend on modifying. Not on these steps which go before, but actually modifying, fixing bugs, improving, adding new features, and so on and so forth. So they say the design is everything. So design is how you, what they say, conceptualize, frame, implement, commission, and so forth. So think about design not as a single individual phase of inside the full cycle of software development, but something more specific. So this is the agenda for this lecture. First, we're going to compare the software versus interiors and see what's similar. Then we go for the standard. I'll introduce you to the standard, which is called IEEE 1016, which defines how software should be designed, how software design should be documented. Then I will introduce you to software architecture document in the rational unified process. That's another approach to software design, which also was introduced many years ago. Then I will introduce you to the technical solution area in CMMI. That's another approach of how software design should be done. Then I will show you what is software engineering body of knowledge book. This is also something that you need to read if you consider yourself a software developer, a serious software developer. And then we go for README, which you know without me. Then we'll talk about README and how README should be done these days. And finally, in the end, I will suggest you the books to read. I will suggest you the venues where you potentially can publish your papers, academic papers, if you become not only a software developer, but also a scientist. And I will suggest the call to action. The call to action, at the end of each lecture, I will show you what you can do in order to practice what I teach you during the lecture. Make sense? That's the agenda. And unfortunately, I don't have the timer, so I don't know how much time is left. So please forgive me if I finish earlier or finish late. So let's go. First, chapter 1, software versus interiors. So if you look at them, that's the comparison I'm suggesting you to make. If you have the interior, which is on the top left corner, a nice, good-looking room, which is designed well, which is the interior, which you like, then in the top, and then in the left bottom corner, you see the interior design. So that's how interior designers, they put the design on a piece of paper. In order for room or a cafe or a restaurant or an apartment to look great, the designer, interior designer, has to draw on the paper how this interior should look. So that's the interior and interior design. If you look at the software, for example, Docker, who knows Docker? You see how many people use Docker, and it's quite fresh and very, I mean, I love that software. I think it's very well designed and very popular. So if you look at the Docker, then inside Docker we have software design. So software design is a set of diagrams, set of documents, set of papers, where programmers put their thoughts of how to design. So you need to understand the difference between the software and software design. Software design, these are the descriptions of how the software should work. What are the pieces, how they connect together, how we wire them together. The same as an interior design. You make a decision where to put the table. You don't make this decision intuitively. You don't say, you know, I would like. You get the piece of paper, you draw the table, you put the measures there, and then you get the design. So the more professional is the interior designer, the more diagrams, the more papers, the more decisions are made on paper, and the more this interior designer follows the standards of design. So in order to make, there are basically two questions any interior designer asks themselves. The question number one is how to design, like how to design or what to design. Like where do we put the table? On the left, on the right, where's going to be the fireplace? What are going to be the colors of the chairs, the colors of the walls? That's the questions of how, maybe not only how to design, but what to design or how to design. That's one question. Another question, you don't see it clearly, huh? Maybe we can turn off the lights, yeah? Right. Better? A little bit, huh? So there are two pictures. One on the left, it's a diagram with the design. The picture on the right is the photograph of the design. So the designer has to answer two questions. What do we design? Where do we put the chairs? And then how do we explain it to people who implement the design? So you cannot be, my point is that you cannot be a good designer if you don't know how to draw UML. So you cannot be a good developer and claim to be a good developer. Like I don't need UML. I don't need the software design documentation. I don't need to know about this IEEE standards because I'm a hacker. I open the laptop, I write the code, 3 hours later my code works, who cares? No, you will be like these designers who don't know how to explain, like interior designers who don't know how to explain their thoughts. They just know the colors, they're decorators, but they're not interior designers. So you don't want to be that. You want to be software developers who know how many servers to put there, who know which language to use. It's going to be Java, it's going to be JavaScript. They know how to make these decisions, and they can explain those decisions. And to explain those decisions, we're going to talk today how to do it. So this lecture is about how you explain your decisions. What do you use? So don't miss the part which is on the left. I know many people make these mistakes. I did myself too. I also didn't understand what this UML is for. I didn't understand what this documentation was for many, many years. And my code wasn't my design, and my software in the end was not the way I wanted it to be. Because I failed that skill of explanation, and that's the skill you learn now. It will be difficult later to learn, and I will tell you now that there are many approaches to this. So it's not one single approach. So you learn how to do it, you learn UML, and you're safe, you can design good systems. No, you need to know more than that. So my summary, my thought is that I'm suggesting you to think that way, that a good documentation is a precursor to a good design. The good documentation that goes together with the good design. The design, like I'm saying, the design are the decisions you make, and the good documentation is how you explain them. The good documentation, I claim that it goes very often first to the good design. So when you know how to explain, when you know how to use the right diagramming tools, when you know how, for example, to choose the right database, not intuitively, but I'll show you how, professionally to use, then you will, in the end, you will make better software. That's what I thing. Chapter number 2, we will talk about software design description as IEEE. Who knows what IEEE is? Have you heard that? Okay, IEEE, most of you know. IEEE is the large institute, non-profit organization from the America, which one of the jobs, one of the responsibilities of this institute is to make standards. How do they make standards? About 7 years ago. So my name is on one of those standards for IEEE. So how do they do this? First of all, they announce to everybody who wants to participate. You can also do that. You can also participate. If you go to their website, you can find announcements. Sometimes they invite. So who wants to join the work group, so-called work group on a new standard? So we work on a new standard about serverless architecture, for example. And I just voted. Not voted. I volunteered. So I said, yeah, I would like to join. They said, okay, come on in. Well, they check a little bit who you are. You send the CV, they check you, and then you just invite you in. And then they start making discussions, like meetings, every week or every month, depends on the group. And they start discussing, like, let's agree together. There were like 40 people, for example. Let's agree together. And all of these people are developers from different companies. So how do you think, guys, what is a good software design definition document? And all people contribute and give their opinions. And in the end, they make a standard. So in the end, it's like a document which a group of people, collectively contributing is designing. And in the end, you have this standard. So it's not like a one organization, like Oracle, for example. Oracle makes a standard, like this is how, let's say, Java has to work. Even in Java, they have volunteers. But it's not an organization which claims what is right. It's an organization which gets together a group of engineers from the market, and they issue standards. So one of the standards is called IEEE 1016, which says, I quote, the standard is about software design description. It's a representation of software design to be used for recording design information and communicating that design information to key design stakeholders. This standard is intended for use in design situations in which an explicit SDD is to be prepared. It's not a long document. I suggest you check it out. You can download it. Well, actually, you have to pay for it, but you can download it for free. There are many, many copies everywhere, which in about 50 pages explain, let's say you're the designer, the team comes to you and say, please explain how the system has to work. So you sit together and you ask yourself, how do I structure this document? It's not a piece of poetry. It's not lyrics. You need to structure. You need to have some sections, some chapters. You need to know what to put in this document. This standard will tell you exactly how to do it. The standard will say you do this, this, and that. You put this section, you structure it this way. So it's very convenient and very useful documentation. However, the standard is not active anymore. Don't ask me why. I was trying to find on the internet why it's not active. Actually, many standards which were created by IEEE a long time ago. This one was created in 2000. The latest version was updated about 12 years ago, and last year it was put on the inactive status. So I would be a little bit skeptical on relying on this standard fully, and I haven't found a replacement for that. But still, the standard could be interesting to look into. We will look into what's there in the standard, and I will show you the parts which stay in the standard. I actually would like to highlight 7 of them. There are many more. I mean, not many. There are about 10 or maybe 11, but we don't need all of them, but 7 are important. So when you decide to design a new Docker, remember, in 10 years, right? So when you decide to design your new product, then you will need to explain how your design works. I suggest that you open the document and put 7 chapters there, 7 blocks of information. And I will go through all of them one by one. So the first is you put the glossary. A glossary or vocabulary or dictionary, it's the definition of terms which you're going to use in the document. In my opinion, I even wrote a blog post. This is QR code for my blog post about that. So I wrote a long time ago a blog post which says that good design documents, worst design documents, they don't have glossaries. So I think it's one of the biggest mistakes software designers make is when they start writing the documentation and use just English or maybe Russian words in the document without explaining what they mean. For example, here I give you the example of a glossary. Let's say a request is a data package sent from a client to a server. This is glossary. So I defined what is request. So everywhere in the text later where I will use the word request, we will all know what I'm talking about. Most people, most documents which I've seen in my life, they don't have these glossaries. So they just, for many reasons. One reason, people assume that everybody understands what is request. Yeah, we are developers, so who doesn't know what is a request? Who doesn't know what is a server, right? That's one reason. The second reason, for people it's very hard to define what is request. So they feel that the request is something, something that comes from, one place to, another place. But they cannot really explicitly explain what is a request. So they don't define glossaries. They just expect readers to understand it by definition, by intuition. Yeah.
So why do we need to make such a glossary if the software documentation is usually oriented? Like, I don't know, can I say mostly oriented for programmers? Because, for example, who would go and check the README file or documentation other than other programmers? Why would a normal user check the documentation of the software design?
So the question is, why do we need a glossary in the software design document while everything is obvious? Or
why it's oriented for programmers? Is it oriented for normal users?
no, for programmers. The design document is for programmers. Yeah. So what's the point of yeah, that's why people don't write glossaries. They believe that we programmers will understand what request is for. But it's very often when request can mean many different things at the same time. It could be a data package, or it could be, it could be a trigger somewhere. It could be a message posted on a queue. It could be different things. So for me as a reader, it makes it more difficult to understand your document if I don't know exactly what you mean by exactly each word. So I suggest that the glossary becomes something, in your document, something mandatory, which you start your document with. So you define most important terms, most important nouns, explicitly saying what they mean. I think so. I think that's going to be very helpful. Yeah?
Is it practical to put like such glossary like in a more adapted way? For example, like you read the text and you meet word for first time and there is like a small link, like what does it mean? Not put glossary every time before reading because it can contain too many words.
It should be very short. So you're asking like how to format, like how much information to put in the glossary, right? How big it should be, like how much we need to explain about what is request, what is client, what is server, right? That's the question.
My question is to use like dynamics. For example, like every time you meet a word, there is like a link, and for example, there is a pop-up.
Yeah, that would be awesome. Yes, but not yes. That's the ideal glossary. If you can make it like this, if you make the word, so I can move the mouse on top of the client, like the word client, and something pops up, and I know what the client means. That's perfect. Yeah, but sometimes people cannot do it. Yeah. So it's like a wiki page. So for example, if you design your software design description in the wiki page, then you can make it. You can every time highlight the word client, and then I can click it and go to the page. And can I ask you somebody to interrupt me when it's time for the break, okay? Because I don't have clock, okay? So just interrupt me. So that's how the glossary should work. It's a mandatory part of the documentation. And I want to give you one quote which I think is important. So every time you write the documentation, you have to understand that if your readers don't understand you, it's your fault. It's not their fault. Because many software designers, to my experience, what I know from working with technical people, designers, architects, they believe that the more complex their documents are, the more difficult to understand, the better the designers they are. And if somebody doesn't understand them, if somebody doesn't know what is HTTP request, then it's your problem. So if something is not clear, then it's the problem of the receiver of the message. It's not true. It should be the problem of you. If you're the author of the document, then it's your responsibility to make the information digestible by your readers. So if your reader doesn't know what you're talking about, if the reader spends more time to consume your content, your text, then it's your problem. So remember this thought. If I don't understand you, it's your fault. The same for your design documentation. When you write your documentation, it should be absolutely clear to me what I mean, what you mean by every word. Glossary helps you do that. Next is languages. Languages in the, like, remember there are 7 things which we want to see in the software design document. So languages, so which language we are supposed to talk inside the document. So the good designer says, I'm going to use UML. Right, the glossary, here are the terms which we're going to use during the next 5 pages of discussions, of my design discussions. And I'm going to use these languages. I'm going to use UML for diagrams. I'm going to use, I don't know, Java for samples of code. I'm going to use IDEF for database design. So you define the languages. And here I give you 2 examples of a good language and a bad language. So on the left, you see the language which will be suggested to you by multiple diagramming tools. One of them is Microsoft Visio, for example. One of the most terrible tools a software developer can use. So there are many, many tools which you can find, like online drawing tools, draw.io. I don't even want to list them there. There are many, many tools where you can just open the screen, put the rectangle here, put the nice picture of the cloud there. You see they have the picture of a cloud. Then you put the picture of the server. Then you connect them with the nice lines. One line is blue, one line is green. Boom. It looks absolutely attractive, it looks fancy, and nobody can understand you. So this is the bad language on the left. So don't use these diagramming tools. Your software design document is not a collection of fancy pictures. On the right, we have the language, which is, in this case, it's UML. So this is the good language for software design description. And I gave you the link, this visualparadigm.com. I believe this is the best, well, to my knowledge, the best tool. Now that it's available online, so you can just online get there and draw your UML diagrams. So the only language I believe is suitable for software design is UML. It's not the language of pictures, it's not the language of nice pic art, what do you call it, the clip art. This is not the suitable language. The only suitable language is UML, which I suggest you to use with this visual diagram software. When I was using this software last time, there was, I don't know how many years ago, they didn't have the online version. So it was only a question of downloading the software, installing it locally, in most cases paying for it. That was like a few $100s, and then you use it. A long time ago, we had Rational Rose. That was the software for UML design from the company Rational. Now we have this virtual paradigm and maybe something else. So I'm not claiming this is the only tool. I'm just saying that you stay away from anything that looks like nice images, nice pictures, like this on the left. This is the indicator of a very bad designer. So it's like an interior designer. Hold on a second. It's like an interior designer who would, instead of the floor plan, will give you a nice picture with the colors and say this is the floor plan. That would be considered unprofessional because we don't need you to be attractive. We don't need the floor plan to be attractive. We need it to be precise. We need it to be understood by the people who put the electric sockets there and to people who put the furniture there. We don't need to impress them with the colors. We need to tell them exactly what we mean. And the picture on the right tells exactly what we mean because we have a language defined. UML is a very strict language. And if I draw a line with the circle at the end of the line, I mean something by exactly this circle. So it's a message to the reader. So everything on the picture has to be a message. What kind of message is here? Like, for example, why this area on the bottom is green? Nobody knows. And in order to explain it, we need some explanation there. We need to write some text below. Like, you know what? This text, this green area is green because of that. And the text branch off is red because, I don't know why, because the text on top of that, this asterisk server is black. So this is black, this is red. What kind of message is that? Like, does it mean something? Or the designer was just trying to be impressive and just met the color the color button there. And okay, yeah, I like to be, you know, my mood is red now, so I just put it in the red. So the message is probably is there. Maybe there is a message. Maybe it means something, the black and red. But most probably no. On the right side, we have no hidden messages. We have white paper, black diagram. If it's a circle, then it's a circle. We know what it is. We open the book about UML, we read it, and it says the circle at the end of the line means an interface provider. That's it. There is no book in the world which will tell you why branch office is in red. You will not find it. There was a question.
Why do you even keep pictures that enough? Pictures can enhance the understanding of the program. The developer likes of this program means something in particular. And what is the problem with legend? The text that explains why that thing was red and that thing was green.
Pictures are nice. With pictures we explain things. But like you said, in order to explain why the branch office is in red, we need some extra text there, which will explain why it's red. Or we may skip the explanation. We may say we just feel it like this. I just like my text to look red because I like it to be red. But in this case, there's some hidden information which I, as a reader, don't know what to do with. Like, do I need to process this information? Does it mean something for me because the text is red, or I need to ignore it? You know? So for me, it's harder to read this picture on the left because I don't know what it means exactly. Like why, for example, internet there is in bold font, and on the left things, they're not in bold font. Does it mean something? Maybe I need to, I don't know, what's the difference? So they give me visual information without actually meaning anything. And that makes reading very difficult. Let's go next. The next part is, remember we're talking about software design description document, which in my opinion, at least 7 sections according to IEEE format. So the next step, you, if you're the designer and you're making this description of your design, you need to mention the stakeholders of your document, of your product. Stakeholders, who understand the term stakeholders? Okay, stakeholders are people and organizations, actually this is to say this part, is somebody who cares and who is impacted by the decisions made inside this product, so by the product. For example, you design a new Instagram application. So who are the stakeholders? First, the user who clicks the button and posts the pictures. Next, other users who watch these pictures. Next, the server providers who will give you the servers, so you host those images there. Next, the network providers, so they will give you the facilities so your servers can transfer the data and so on and so forth. Second, copyright owners, the owners of the rights for the pictures. If I post the picture which is stolen, then it's going to affect somebody, some organization who owns this picture, and so on and so forth. Your job as a designer is to list those stakeholders. If you don't do it right, if you miss somebody, that is going to be serious concern for the product. And I quote here PMBOK. Who knows what is PMBOK? Project Management Body of Knowledge. This is the book which you, if you really consider yourself a career in software development and software engineering, you absolutely must read this book, and you need to know what it's talking about. This book is a standard which defines how we manage projects. It's quite a large book. It defines all the rules and ideas about how projects have to be managed. It's quite large, it's a big book with all the stakeholder area is just one chapter, one section there. There are many things there, like how do we manage cost, money? How do we manage scope? Like what needs to be done, what doesn't need to be done? How we manage schedule, like how we plan things? How we manage risks? How we plan quality? So everything, if you consider yourself a project manager, maybe you, in the beginning, you will be a software developer, a programmer, but eventually you will consider a career of a team lead, of a project manager, then you will absolutely need to have the knowledge which is there in the PMBOK. So all the books you can meet about managing projects, they are nothing comparing to PMBOK. So if you're serious, then PMBOK is your destination. You will eventually end up there if you're serious. Otherwise, you will read the books about leadership, about lean startups, about fancy pictures, but it's not about real management. Real management is PMBOK. So I just quoted here to give you about the idea about stakeholders. But the main reason for showing you the picture is to provoke you for actually considering, did you have a course about project management? No. Are you planning to? Will you have to? You will. Agile and Scrum is just 10%, maybe 2% of project management. So Agile and Scrum is just fancy, nice idea how to be lazy and get a good salary. But PMBOK is about actually managing things in large-scale enterprise projects and small projects as well. Next chapter is concerns. We will talk about them later today. After this lecture, we're going to talk about requirements. So basically, concerns is what comes to you as a designer as an input. So when you start designing your new Instagram application, then you need to know what are the concerns, or basically functional and non-functional requirements to you from the customer. So who gives you the money? Maybe there's no money, maybe you just decided by yourself, but still you need to specify what are the concerns. By concern, I mean for something like that. For example, I would like to have this application a post button, which is clickable, and when I click it, there's a, I can upload my picture, and the picture goes to the server, and it's visible to everybody else. That's my functional concern, so I want it to happen there. Another concern may be non-functional. For example, I want this picture to be uploaded, and I want to get it to other users in less than half a second. So it's not a functional requirement, it's a non-functional. So I want it to be there I post it, you see it, but in less than half a second. That's a non-functional requirement. So you as a designer, you start working with the software only after you understand the concerns, only after you specify requirements. We're going to talk about this in half an hour on the second lecture. But now, just remember that this is very important part, probably the largest part. Maybe not the largest, it's a big part, but not the largest, but it's an important part in your design documentation. So when you write your design documentation, you say, this is my glossary, these are the terms I'm going to use. Then you say the language, I'm going to use UML, I'm going to use IDEF or something. Then you say, okay, my stakeholders are this, and that, those organizations and people, and now this is what they want from me, these stakeholders. The user wants the picture to be posted and quickly available for everybody else. The copyright owners, they want to be able to submit the complaint and the picture to be removed in less than an hour. The server providers, they expect my system to not overload the servers for more than 80% and so on and so forth, et cetera, et cetera. So you explain those concerns by all the stakeholders who are sitting around your project. You must do it, it's your job. The next one is viewpoints. Viewpoints are like the angles at which you look at your design, at your product, and explain how it looks from different angles. I posted the picture from, I don't know, I got it from internet. So who of you are familiar with, I don't know how to say it in English, the drawing skills? Like, can you draw the same? You can, some of you can, right? So I liked it in school when they give you something like this, and then leave you for a few hours, and you have paper where you present here, you see 1, 2, 3 viewpoints. So you say, if you look at this thing from this viewpoint, then you're going to see a circle. When you look at this thing from another point of view, then you're going to see a rectangle. If you look at it from this point of view, then you're going to see something different. So why do we give these 3 viewpoints? Because 1 is not enough. If you give just 1 on the left at the bottom to somebody who is supposed to make that thing, they will not be able to make it. They will make you a circle. So the people who use the metal and use the actual things and tools to create the same part, then they need to know how it looks from different viewpoints. And sometimes 3 viewpoints is not enough. Sometimes there have to be 4, have to be 5, it have to be as many viewpoints as you think are enough for people who make the tool, to make the part, so to make it exactly how you want it. The same for software. So you think, okay, I'm going to make another Instagram. So you say, my first viewpoint is, how about I show 1, 2, 3 servers, so 3 rectangles, 3 servers are connected together through the router, and then the router is connected to the network. Cool, that's my first viewpoint. So the developers who will implement your design, they will see, okay, there are 3 servers, they buy 3 servers, they buy the router, they're connected, good. And then they question, and where's the database? And you say, yeah, and you thought, yeah, the database is there on one of the servers. And I say, how did we know? You didn't show it to us. So give us another viewpoint, the data viewpoint. And then you say, okay, now let's look at one of the servers. What's inside this server? Oh, there's a database MySQL server installed, and there is installed, I don't know, the traffic dispatcher, the router, and then there is installed some backup solution, and then there is something else and something else. So you put some components into one server. That's another viewpoint. And then they say, okay, and what's in the database? Like, is it SQL or no SQL? Yes, it's SQL because it's MySQL. And what's the schema? Like, how many tables there? Oh, I forgot another viewpoint, which will show you how many tables are there. That's the viewpoint, the data viewpoint. So you have component viewpoint, data viewpoint, process viewpoint, deployment viewpoint. So different perspective at which you look at your system, and you make them more and more and more until you're done, until you say, I said enough. So now it's impossible to make the system in the way that it will contradict my design vision. So your job as a designer is to make those viewpoints, is to make them as many as you can. Each viewpoint, it could be a diagram, it could be a picture, it could be description in text. It has to be, you know, your view on what's going on with the system from one angle. That's part of your document. Next one, you will have to say things about elements. So from this, on these viewpoints, you will show, I have 3 servers, I have the database, I have this JavaScript component, I have piece of Java. So each of these elements, it will be elements. That's what IEEE say. They say there will have to be elements, and each element you're supposed to explain. So you have to say something about the elements. So you list those elements and you say some textual information about each element, as much as you can, element by element. So you explain, I have MySQL in my design. I see that there has to be MySQL version this and that. And it has to be installed on this computer with this amount of disk space. And it has to be the master data, the master MySQL. And the slave MySQL has to stay on another server. So you explain the element from all the possible details. The more you say about the element, the better. And the final part, the most interesting, which I like most, is the rationale. Rationale is actually your explanation of why you made those design decisions. For example, I read your document, I read your design description document, and you say in the document that we're going to use MongoDB. Who knows MongoDB, by the way? Oh, so you said you didn't know about NoSQL. Now you know MongoDB all of a sudden. So I'm going to ask the question, why MongoDB? Why not MySQL? And if I don't have an answer in your document, then there will be a problem. Then I will not trust your document. Then I will not like your document. So you have to explain to me why. And explaining means not explaining with just words trying to convince me, but you have to use, there's many names for that. I believe you don't know many of them. Me neither, actually. But I understand that in most cases it goes down to listing the criteria which are important, and then listing the options which you consider. And then you show me how these options are not matching the criteria, and how one option matches all the criteria perfectly. So you say, for example, my database, like first the criteria. So you say, while selecting the database, we think about it has to be fast, not just fast, but less than X amount of milliseconds per request. Second, it has to be small. It has to be open source. It has to be easily installable. It has to be, it has to support sharding. It has to support multiple servers, and so on and so forth. So those are your criteria. So you put them like columns in your table. And then horizontally you put options like MongoDB, MySQL, Postgres, Oracle. You list them all. And then you say yes, no, yes, no, yes, no. Or maybe some weights, like it's more suitable, it's less suitable. And then you somehow calculate it. And then you put the decision. You say, you know, by all my criteria, actually MongoDB was the best suitable option. In this case, when somebody will read your documentation, they will open it and they will understand that you did the analysis. It was not your emotional decision. You didn't just judge by intuition, but you actually made an analysis, and you can use the decision matrix, multi-factor analysis, decision table, architecture trade-off analysis method. I don't even know what it is. I just got it from Wikipedia, and you can get more of those names. So there's even like people write PhD studies about this methods of decision making, because sometimes it's not so easy. Sometimes you list the criteria, you list the options, and then you compare, and two options are suitable both. And what do you do next? Like, how do you make the decision? Or maybe sometimes some option falls off because one criteria is too expensive and overweight all others. And still, in this case, you still may consider that line, that option, because. So how do you make the decision? It's an interesting topic to study, to analyze, to think about. But in the end, you have to convince me as a reader that I can trust your decision, not you. I don't want to trust you as a designer. So be prepared for that. I even made a for you. So don't expect them to trust you. Make them trust your decisions. So you as a designer, you will face in your real life after graduation, you will go to real companies. And who of you work right now already with in a real company? About 5%, maybe 10%. So most of you will work, I believe, I hope, will work in real projects, and you will face issues with trust. I mean, not trust you as a person, but trust your decisions. So you will come to your boss, you will come to your team and say that I believe MongoDB is good because, you know, in Innopolis we had a good lab about MongoDB and they taught me MongoDB. So how about we use it? And they say no, all of them. They say no, we like MySQL because we like it and we use it for years. And you will get frustration from that. I know many people who quit their teams because the team doesn't listen to them. Because the team says, I don't care about your ideas. We don't care about your ideas. We don't care what Innopolis told you. We just do what we do. And we do it for 10 years already. Yeah, we do it wrong. It's slow. It's not modern technology. It's all old, but it works. So go back to Innopolis if you want like interesting stuff. Here you're going to do what we do. And many people quit because of that. They go to a team, they go to a product, they work with they think it's a good project, they think it's a good company, and then they quit because nobody listens to them. I think it's our fault that they don't listen to them because we cannot present our ideas in this way. Because we present them emotionally. I feel it. I feel that MongoDB is so good. I know. Listen to me. Because I'm smart, because I care about the product, I care about the company. That's how we do. But people don't listen to that. You need to learn how to present your rationale in the way that people will trust you. How you do it? In multi-factor analysis. It's one of the methods. You just put all the options, compare them all, and say, look at the numbers. Compare databases, compare the programming languages, compare design patterns, and then we make a decision.
Yeah, the question. So we have all these factors and different aspects of the system, but where do we describe how actually things work, scenarios or something? Because right now it's all static and no movement.
In viewpoints, here. How it works, you design in viewpoints. So each viewpoint is like an explanation of how it works. The viewpoints can be static and can be dynamic. We'll go by how to design it. But you can say the static explanation, how you put the servers together. Dynamic explanation, how the systems interact with each other, how they connect to each other, what are the flow of data, how they interchange with data, who connects to who, what are the formats of data. All of this goes into viewpoints part. Yeah.
So as far as I know, this software design is the role of the project manager. Am I wrong?
No, you're asking whether the project manager has to write all of this or the software designer. I think it's the responsibility of an architect or a designer. That's the title of the role. Project manager, in my opinion, is somebody who knows nothing about these viewpoints, nothing about UML, nothing about software. Project manager is somebody who manages things, who tells you what to do, who tells me what to do, but it's not the person who is technically capable of replacing us. So there are two major roles. We can talk about this also in some of the lectures. There are two major roles in any project. It's a project manager and some people call CTO, or technical lead, or technical architect, or just an architect, or designer. So the project manager is the person responsible for the plan during the next half a year. The cost, who gets how much during the next half a year. The timeline, when it will happen, when you finish your task, when another person starts the task, when they connect the tasks together. So project manager is responsible for scope, cost, and time. You probably heard about this. It's called management triangle. Management triangle. Cost, scope, and time. So the project manager is responsible to put these three pieces together. The technical person doesn't care about that. The technical person only tells how things technically have to work. And the project manager asks the architect, how do you think, how much time it will take? The architect says, I think the design will take 3 days, and then implementation will take 3 weeks. And the project manager just writes it down. The project manager doesn't know whether it's true or not, 3 days or 30 days, I don't know. I'm just asking the technical person. So that's how they work. The project manager gets the information from the technical, from the architect, and then puts the information into the plan. We'll get to this too.
What's the difference between viewpoints and elements?
What's the difference?
Yeah.
Yeah, it's a good question. So what's the point? What's the difference between viewpoint and the elements part? It's a good question. I also don't see much of a difference. I understand that viewpoint is when you show how elements connect together with each other. For example, server, 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 and then the lines connect them. And the element is one server, you take it away from the diagram, and then you in the text explain how this element has to be implemented. So that's, I mean, in some cases, it's very unclear line between them, but that's how this document expects us to do it. No more questions? So, rationale, you put it this way, and if you do it wrong, they don't trust you, it's your problem. If you graduate from here and you go to a company and you work for join the team, and this is, I'll guarantee you, that's exactly what will happen. You will see that people do things wrong. You will try to change them, to change the way they work, how the architecture is designed, many decisions. The moment you try convincing them emotionally and say that, please believe me, I know how things work, that's the end of your career at that place. You have to present them your decisions with a grounded explanation with numbers. So learn how to do it. And don't expect them to trust you. They will never make them trust your decisions. We go next, software architecture document, rational unified process. We will talk about rational unified process tomorrow a little bit. So today I just say that the rational unified process is something that people invented many, many years ago in order to discipline programmers. We will have the whole lecture about that. That's how people were doing things in one way, and they decided, okay, how about we give people explicit roles? How about we tell them, you're the designer, you're implementer, you're manager, you're test designer, and so on and so forth. And then we explicitly design how these roles have to be connected to each other. And one of the roles is called software architect in this large process for designing, for organizing teams. If you look at this read this book and you look at the rational unified process, you will see that there are many roles and many documents, and many processes which it explains, which is also I highly recommend to read. Because nothing better than rational unified process so far haven't been invented in the area of software development. So this is by IBM. Well, originally it's the company called Rational, and then IBM acquired that company, so now it's IBM Process, which is something that you definitely need to know if you're serious about software development. So they have software architecture document. They have many other documents, like many. So one of the documents is software architecture document, which is similar to IEEE. I'm just now giving you examples of how other standards and other documents exist about your work. So let's say you become the software designer. So you need to know how you will design your software. According to what? One option you're going to say, I design like IEEE recommends me. Another option you can say, I design how rational unified, right, like RUP recommends me. I take the template from there. They even have the template for the document. You get the template from RUP and fill it up, and then you say, my design is by RUP requirements. I suggest to go for IEEE, but just for your information, this is RUP as well. Another document which is interesting is called CMMI. CMMI, it's also something you definitely need to know. It's a large standard by Carnegie University, which they defined, I don't know, maybe 15, maybe 20 years ago. It's a standard for software teams, which says how software teams have to be organized. So if you want to organize your team in the right way, not according to books about agile, but actually according to some more or less formal standards, so you know, so you make your success predictable, then one of the sources of information you can go for is CMMI. You download this document, it's like I don't know, 500 pages, and it explains all the areas. It explains how you do project management, how you do testing, how you do people management, how you analyze risks, how you plan, and so on and so forth. So they have one block, one area, knowledge area, or they call it, process area, which is called technical solution. In technical solution, they explain how people should design software. So they say, when you design the software, you create a design document, then you don't forget about this, don't forget about that, don't forget about that. This is yet another standard which you as a software designer has to know. So if you are a serious software designer, you have to know IEEE, you have to know RUP, you have to know CMMI, and also it will be good for you to know software engineering body of knowledge. That's the book which is less detailed, instruction for software designers and software developers than things I showed you before, than RUP and then CMMI and then, of course, IEEE. So Swebook, I don't know how to spell it, Swebook, it's more like a free collection of thoughts and references to interesting books about software development. And they have the area, they have the chapter which is called software design. So you download this book. The book actually summarizes everything you need to know about software engineering. Everything. So what you go for in Innopolis, you can get from one book, but very high level. So for software design, they have probably, I don't know, maybe 10 pages. So in 10 pages, they say software design is this, you do it like that. When you do it, please read this book, and then read that book, and then read probably about design patterns, and then read about that. Thank you very much. So that's what, it's like a body of knowledge. So they're trying to show you what you need to know and what not to miss. If you're serious about software development, you have to know about this book, you have to read it. It's sort of a standard, but it's not strict. Like I said, it's just a collection of guidelines, it's like ideas and references to books. If, for example, CMMI refer to no books, to my knowledge, they don't refer to anywhere. They just say, this is the right way to do it. We just suggest you to do it this way. But Swebook is actually telling you where to read the information. 10 minutes. Okay, so, and then my recommendation, if you will be requested to, if your next employer will request you to develop the software design document, ask you to do it in Microsoft Word, my suggestion to stay away from this format as far as you can and use LaTeX and Git together. That's just in general recommendation. So Word is terrible, and your documents will look ugly. And the final chapter, README. This is what you know without me. So GitHub changed this whole story, they turned this whole story upside down. Now we're getting closer to what you do, guys. So README is something which, people, me as well. I don't write this long stuff, I don't refer, I just know about this. I read about RUP, I read all the paper, all the books I showed you, I learned all that. But now I use README files. So in README file, we just use Markdown, and we open the new repository, we create new README file, and in one long README file, we explain everything we need to explain about design. So we make it easy, we make it simple, we use Markdown as a format, that is organized. So now we don't use any more this old documentation, which is great. So I suggest you to stay away from this long Word or whatever documents and use README file. One repository, one long README file, which explains everything. How to use it, what are the requirements, how the design is done. Although it's not so easy sometimes, we'll talk about that. One more thing which you may need while designing the software are the UI mockups. Who knows about that? Okay, so probably there are mobile developers here. So UI mockups is something which it's one of the viewpoints actually. It's one of the viewpoints. You have UML and you have UI mockups where you design the interface. So you say when the mobile application will be used, people will just click the first screen, the next screen, the next screen. So you put the screen to screen to screen. This is called, these are the websites where you can design it as well. Make these mockups. So you just open the website, you put this is my first screen, my next screen, and then together you make the viewpoint, which we discussed before. This is one of the viewpoints. Then you give this viewpoint to programmers, and they know exactly how you want your application to work. You want your application to have these multiple steps from left to right. Yeah?
Is this, let's say, a separate job? I know that there are UX UI designers who are just responsible for doing this.
Yeah. Yeah, that's right. Good question. So we may have in the team UI designers, UX, UI designers, who will do this mock-ups. So why we talk about this here when we talk about software design? If the system is large and you have people responsible for UI and UX, then they will make it for you. But let's say in this team you will be the software designer, the architect who will stay on top of these people. So you will have people responsible for database design. They exist. We call them database administrators, database designers. We have UI designers. We have Java designers. We have people, different people who design different things. And somebody stays on top of that, and that person is one of you. So you have to know that you will be, I'm just giving you one of the tools. So one of the tools for the design is UI mockups. They call mockups. That's the name we use right now, mockups. So they mock the design. They're not real design. It's very fast. You can do it in like half an hour. You can design the whole Instagram application in maybe a few hours. All the screens. And this software, they will even make it dynamic. So you design it, design, and then you click run, and it starts working, starts acting. So you will see a mobile application, how you click through it. It will go through all the buttons, click all the buttons, it will demonstrate you how it works. It's very visual, which is great. For a viewpoint, it's very visual. And final line about README. So I suggest you to use README. I suggest you to be as, brevity is a virtue. Brevity means you have to be as short as possible. So when you write your documentation, when you explain your design, use as few words as you can. Your text has to be as short as possible. The longer the text, the more words you use, the worse is your design, the more difficult it is to understand. So make it as short as possible. Long text is not welcome. And redundancy is a sin. Redundancy is when you say two different things, well, you say the same thing at different places of the document. Here you said how you upload the image to the system. Here you explain it again, but from a different, with a few more words. That's redundancy. So every time you need to repeat yourself, every time you repeat yourself, it's very bad. The more text you write, the worse is your documentation. So that's all design. Like what will be the design? We'll discuss in the next 15 lectures, like how you make the design, what you put together. Here we discussed how you present it. And this is the final line. So be short, follow the standards, know about the standards, read about them, and that's how you become more professional. And now I'll give you the books to read, the venues where to publish, and then a small call to action. First, the books. I highly recommend these two books. These are, in my opinion, extremely formal, extremely boring, but I read them both, and then one of them I even wanted to return to Amazon because I found it super boring. But if you go through them, you will be very professional because they explain all these viewpoints, all the details of how to present, not only UML, they show UML as one possible way to present your information. So these are two really fundamental books about software design, about how to explain software design. Not how to design systems, but how to explain what you design. So that's my recommendation for you. The place where to publish, there's a really large international conference if you go for academic, like scientific direction. If you want to say something new in the area of software design, then this is the conference to publish, International Conference on Software Architecture. So when you invent some new idea in the area of design and architecture, that's where you go. And finally, call to action. So I suggest if you want to play a little bit, then that's like a homework. So try to create and explain the design, let's say an application which is QR code generator. So you understand what it is. So I give you the text, the URL, and you generate the QR code. That's the application. Make it web application or a mobile application, doesn't matter. So create the README file in a new GitHub repository. And explain there, just like we discussed today, with all the blocks we discussed, with the stakeholders, with the glossary, with the viewpoints, maybe some diagrams. So explain how your application, imagine you're the designer and you have a team of programmers, 10 people, sitting and waiting for you. Like, what do you want us to write? And you explain your idea in one long README file. That's your kind of a homework. And final slide, I will show you what I think are the unresolved issues in the area of documenting design. That's my last slide. I think well, there are many unresolved issues, but these 4 things I think people don't know how to do. First of all is how to synchronize this SDD, the software design document, with the source code. It's a very typical problem. When you design something and then programmers start writing code and they do it differently than you planned. And your design document gets expired. It's not active anymore. It's not in sync with the code. So the code goes away and the design stays the same. And in some time we just throw away the design. Especially in large projects. They design a very large documentation, they explain everything very well, they make UML diagrams, and then the bunch of programmers come in and say, yeah, sure, but we'll do it a little bit differently. And they do it differently, it works, everybody is happy. What to do with the design document? We just throw it away. Some people say it's okay to throw it away as long as we have the software, right? So we made the product, but I don't think so. I believe it's still a possibility for us in the future to invent how we can somehow synchronize back, maybe automatically, how we can look at the software and maybe update the documentation. That's the further research for you to think about. The second point, design. That's the problem many people for many years trying to solve. Like, how about I design my software in UML and then click one button and boom, the software just works. How about I put the components, the classes, the lines, everything together, click one button and it works on the server. It's still, well, I don't believe we have a solution. I know that there are products which suggest that they can do it, but none of them really actually work. We practical programmers, we don't use that. Number 3 is how to embed diagrams into the source code. You can try, if you do the homework I suggested to you, to make this README file with the design description, then try to put diagrams there. You will see how difficult it is, how impossible it is. So one way is to go to diagramming tool, draw the diagram, make the picture, and embed the picture here. But in this case, you lose the ability to go back to the drawing tool, change the diagram, and automatically change it here. You will always have to get it from here and post it there. Get it and post it. In Microsoft Word, for example, you can automatically edit the diagram inside the document, which is the benefit of Microsoft Word. But if you go for README, then it will be much more, it's not so clear. So try it, and I think this problem is not solved yet, even though there are some solutions. Yeah?
ASCII art solves the problem?
ASCII art solves the problem, yeah. It's not exactly the good diagramming, but probably. But if you want some graphic, then you think how to do it. Maybe you can invent something, because I saw some tools, but none of them actually is perfect. And the code versus the description, the design. So let's say I designed something, and then the team of programmers working on implementation. How do I know that they do what I planned? Can I check it? Can I make sure that they do exactly what I planned? So far, I don't know. Well, there could be some solutions, but I don't know anything which we practical programmers would use right now. So those are 4 directions for you potentially to work on in the future. Thanks. That's the end of the first lecture. See you in 10 minutes.